Assalamu alaikum. In this session, we will explain the last part of Chapter 10, Current Medicinal Drugs. At the end of this video, you will be able to define and classify antibiotics, differentiate between broad-spectrum antibiotics and narrow-spectrum antibiotics, describe the resistance of bacteria to antibiotics, and describe the possible side effects and overdose effects of an antibiotic. Before to start, you have please to prepare your pencil, papers, and your chemistry book. Now let's start our lesson.
Hello, my name is Alexander Fleming. I'm a doctor, and just under 100 years ago, I discovered penicillin. Quite by accident. This is the story of what happened. Do you know, I'm an untidy kind of person, and my lab was always very messy. Old food, manky test tubes, uneaten sandwiches, and dirty lab dishes that I never washed up. But you can tell your mum that being messy can sometimes be a good thing. I left my laboratory in a big old mess when I went off on holiday. When I got back to my lab after the holiday, I noticed that one of my dirty dishes had grown a big blob of mould on it. Just like if you didn't wash up your cereal bowl, it would go green after a few days. That's funny, I said. And then I saw it! All around the green mould in the dish, the bacteria were dead. That gunky green mould had killed everything near it. The mould was called penicillin, and it was amazing. It could kill germs.
Boring idea. It'll never work.
10 long years went by without anyone noticing my amazing discovery. Until one brilliant man did. So the first thing we had to do was find out if this penicillin stuff did actually kill infection. Our patient was a policeman who had scratched his eye on the thorn bush. His eye had become all gooey and green, and it looked like he might die. And guess what? The penicillin did work! The infected area around his eye disappeared. Soon we had mountains of it. Enough for everyone. Since that time, in 1945, penicillin has become the most often used antibiotic in the world.
So what are antibiotics? Antibiotics are chemical substances produced by one microorganism, natural antibiotics, or by chemical synthesis to kill or inhibit the growth of other microorganisms. Antibiotics are classified in two ways. Based on the nature of targeted microorganisms, they are classified in two groups: bactericidal, that are antibiotics that kill bacteria, and fungicidal, which are antibiotics that kill fungi. And based on their spectrum of action, are classified into broad spectrum, means effective against a wide variety of microorganisms, and narrow spectrum, which are effective against a specific microorganism. But when do physicians prescribe each class of antibiotics? Broad spectrum antibiotic is prescribed when the invading microorganism is unknown. It may kill some beneficial bacteria, like amoxicillin, while narrow spectrum antibiotic is prescribed when the invading microorganism is identified, like vancomycin. Like all other medicinal drugs, antibiotics have many side effects. They cause diarrhea since the use of antibiotics upsets the beneficial bacteria that lives in the large intestine, and the overdose effect of penicillin cause dizziness, hallucination, troubles in perception, and intense contractions in heart and limb muscles. Some bacteria could develop resistance to antibiotics, which is the ability of bacteria to resist the effects of antibiotics. A bacterium that cannot anymore be eradicated by antibiotic is called resistant. Resistance could be natural or acquired. Usually in presence of antibiotics, bacteria is either killed or its growth inhibited. Antibiotic resistance is a phenomenon in which bacteria is not affected by the antibiotic. But what are the mechanisms of bacteria resistance to antibiotics? We have 4. First, efflux of antibiotics. Usually, antibiotic enters the cell and results in cell death or inhibition of growth. In efflux mechanism, the bacteria makes a membrane protein that removes the antibiotic out of the cell. As the antibiotic is removed, the bacteria cell is not affected and the bacteria survives. Then we have the modification of cell membrane permeability. In this mechanism, the bacteria modifies its membrane so that the antibiotic cannot enter the bacterial cell. And we have mutations at binding sites of antibiotics. There are specific binding sites of antibiotics on ribosomes of bacterial cell. If these binding sites are mutated, the antibiotic will fail to bind, then protein synthesis and bacteria growth continue, as you can see in the figures. The last kind of mechanism is the enzymatic inactivation. In this mechanism, the antibiotic is enzymatically inactivated to an inactive form which is ineffective. Now, finally, how to avoid bacterial resistance. First, you should take antibiotics as prescribed and complete the entire course even if you feel better. So it's not enough to take only 2 pills and stop when feeling better. Do not save antibiotics for future use. Do not use someone else's antibiotic. And the most important thing, do not take antibiotics for a viral infection. Now you have please to read your book pages 129-130, study summary sheet 5 and solve exercise 2 of the first session of 2012 part 3. Thank you for your listening.